Hello everyone. In today's class, we are going to learn thermal capacity or heat capacity. Yes. So see here the new topic, that is thermal capacity or heat capacity. And it is denoted by capital H. Okay. Thermal capacity is denoted by capital H. So how you can define this thermal capacity or heat capacity? Let's see its definition. So see, before we have learned Q or delta Q is equal to ms delta theta. This delta Q is what? Heat supply. Next we have learned specific heat capacity also. The specific heat capacity definition we have written like this: amount of heat required to raise unit mass of substance by 1 degree Celsius. Yes or not? Thermal capacity means what? See, it is a heat required to rise the temperature of whole body, not unit mass, whole body. Got it? So see, I am writing definition. It is amount of heat required. It is amount of heat required to rise the temperature to rise the temperature of the body in bracket. I am writing mass m, not 1. Okay. So it is amount of heat required to rise the temperature of the body of mass m, we can say, by 1 degree Celsius. By 1 degree Celsius. So here, if I want to write the formula of this, see here, that is, we can say H is equal to delta Q by delta theta. So if I am writing this delta Q, then delta Q is equal to what? Ms delta theta divided by this delta theta. Hai, this delta theta and this delta theta will get cancelled. What I am getting H is equal to m into S. This is what? Thermal capacity. Yes. So where H is thermal capacity or heat capacity, we can say thermal or heat capacity. Next, m is what? Mass of a substance. Mass of a substance. And S is what here? Specific heat capacity. So specific heat of a substance. Specific heat of a substance. Understand? So what is its SI unit and CGS unit? See here. SI unit for this specific heat, you can say this is ms. What is this? Ms. So here SI unit will be joule per Kelvin. Joule per Kelvin. And next one, even from this also you can take delta Q is what, joule, and delta theta is what, Kelvin, right? And CGS unit is what, calorie per degree Celsius, right? And you keep it in mind, H depends on mass and nature of substance. That's it. So H, that is thermal capacity, depends on mass and nature of substance. Understand what is this specific heat, what you can say, thermal capacity or heat capacity, nature of substance. So this is what about the thermal capacity or heat capacity we can say. Understood? So see, very easy. It is amount of heat required to rise the temperature of the body, that is of whole mass, complete mass by 1 degree Celsius. And formula is H is equal to ms, CGS and SI units. And H is depends on mass and nature of the substance. So note down this. Okay, next. See now, one note point I am saying. Let's take this as a note point. See here. Now, two bodies have the same heat capacity. Have the same heat capacity. Means for the two bodies, H will be same. If they are combined to form a single composite body, if they are combined, if they are combined to form a single composite body, to form a single composite body. Show that the equivalent specific heat, show that equivalent specific heat equivalent specific heat of this composite body is independent of the masses, independent of the masses, independent of the masses of individual bodies, of individual body. Okay. Let's see what is this. Now see, two bodies have the same heat capacity. So let's take two bodies. We can say I am taking this as a body 1. Okay. And then I'm combining these two bodies to one another. Something like this. Okay. So let us suppose if this body is having mass m1, specific heat s1. This body is having mass m2, specific heat s2. And this total is having how much mass? m1 plus m2. And let it is having specific heat yes. है ना? Right? Understanding? Body 1. This is body 2. And this is what? Composite body. Composite body means which is made up of 2. Right? Okay. Something I have taken like this example. Right? Now see here, they are having same thermal capacity. Yes, they have same heat capacity or thermal capacity. So therefore, can I write like this? M1 S1 is equal to M2 S2. Why? Because H1 is equal to H2, as H1 is equal to H2, therefore M1 S1 is equal to M2 S2, because they have same thermal capacity. Understanding? Therefore I did like this. So therefore I am getting here M1 by M2 is equal to S2 by S1. Right? Call this equation number 1. Is that clear what I am getting? M1 by M2 is equal to S2 by S1. Now here you see for composite body, for composite body, can I write like this? M1 S1 plus M2 S2 is equal to M1 plus M2 into this specific heat. See, mass of first body, specific heat of first body. Mass of second body, specific heat of second body is going to be equal to what? Total mass into this is combined specific heat. Yes or not? Already I told composite body specific heat is what? Yes. So what I am doing, dividing by M2 on both sides. What I am doing, see here, dividing by M2 on both sides. Concentrate, very easy. Now see here, M1 S1 divided by M2 plus this is S2 only, है ना? M2 will get cancelled, is equal to, here also you see M1 by M2 plus this is M2 by M2 into, yes, here also it will get cancelled. Here I am not writing, है ना? Already M2 by M2 cancelled here, isn't it right? Yes. So now see here what I am getting. I am getting like this, M1 by M2 into S1 plus S2 is equal to, here I am getting M1 by M2 into S and this is plus S again, right? Check it. Check it once. Because here I have multiplied with yes. Okay, let's move ahead. Next, now what I got, m1 by m2 into s1 into s1 plus next one plus s2 is equal to m1 by m2 into s plus s, m1 by m2 into s plus s. From equation 1, from equation 1, what is equation 1? See, m1 by m2 is equal to s2 by s1. क्या है ये? m1 by m2 is equal to s2 by s1, right? Okay, so substitute here. Therefore, s2 by s1 into s1 plus s2 is equal to s2 by s1 into s plus s. This s1 and this s1 will get cancelled. s2 plus s2, 2s2 is equal to, if I am taking here common yes, yes, I am taking common, what I am getting, s2 by s1 plus 1, and therefore you see here 2s2 is equal to s, and take this is nothing but 1 by 1, so you are getting here s2 plus s1 divided by s1. So transfer this s1 here, what you are getting, 2s1 s2 is equal to s into s1 plus s2, and now I want s value, therefore s is equal to 2s1 s2 divided by s1 plus s2. Now see, is there any m term here? No, you are not getting any m term. What it indicates? It indicates that it is independent of mass. Understand? It is independent of mass. So hence we can say that it is independent of mass. So try to do yourself. Don't see the board once you understand. Okay. So pause the video and do it yourself. This is your first slide. You can note down. You can divide on M2 or whatever you want. You can do the operations. And this is your second one. Okay. So do it yourself. Don't see the board. Try to do yourself. Okay. Right. Okay. Let's move ahead. Next topic. Now see, the next is what? Next topic is water equivalent. Water equivalent. And this I am denoting with W. Water equivalent I am denoting with W. What is this water equivalent? Let's see. So first, let's see what is the definition of this water equivalent. Okay, what is this actually water equivalent? Because before we have learned thermal capacity or heat capacity, now this is water equivalent. So it is very simple. I am writing like this: mass of water, mass of water which has which has same thermal capacity, which has same thermal capacity as that of the substance, as that of the substance is called water equivalent. है ना? Mass of water which has same thermal capacity as that of the substance is called specific heat. No, what is that? Water equivalent. है ना? Mass of water which has same thermal capacity as that of the substance is called water equivalent. So let's see what is this water equivalent, right? See here, let let m is mass of body, mass of body. S is what? Specific heat of body. And delta theta is what? Rise in temperature. Delta theta is rise in temperature. Then heat given to a body. Then heat given to a body. Who will tell me? Yes, see, what is you are getting? Delta Q is equal to m s delta theta. We know. Let it be equation number 1. If, see here, next point we can say, if same amount of heat, if same amount of heat is given to W gram of water, same amount of heat is given to W gram of water, and its temperature also rises by delta theta, and its temperature also rises by delta theta. So what you are understanding from this? See, amount of heat given to W gram of water, and this is same because temperature rise is same. Yes or not? So therefore, see here, heat given to water, heat given to water, how I can write? That is Q is equal to W into 1 into delta theta. Why 1 I am taking? Because S of W is equal to 1. Calorie per gram degree Celsius. Right? I am taking this S here. W is what? Mass in grams. Here it is S. Same thing only. right? So this is what again I am saying as delta Q only. So this is your equation number 2. Next point, from equation 1 and 2, what you are getting, m s delta theta is equal to W gram of water into 1 is the specific heat, and this is delta theta. So this delta theta, this delta theta will get cancel, and what you are getting, W is equal to ms. So you are getting formula for this water equivalent is equal to ms, and which is same as heat capacity. If you will see, can you see here, H is equal to ms, here also H is equal to ms, and now I am getting here that is also ms only. But see, keep it in mind, its SI unit is kg or and CGS is gram. SI unit is what? Kg and CGS unit is gram. But heat capacity and this water equivalent are numerically equal, right? Understand? So here SI unit for this is kg, CGS unit for this water equivalent is gram. And keep it in mind, note point, see here, thermal capacity of the body and its water equivalent. This is very, very important. Thermal capacity, you can write here note points. Thermal capacity of the body and its water equivalent are numerically equal. Numerically equal means what? Their value will be same but not units. Are numerically equal. Numerically. And one more, I am writing like this, which is very important. If thermal capacity of a body, if thermal capacity of a body is expressed in terms of mass of water, is expressed in terms of mass of water, then it is called water equivalent. है ना? It is called water equivalent. Understand? These are the two note points which are important, right? So note down fast. Okay, so note down. So now when you will solve problem, now you will understand more. So let's solve one problem. Okay. Let's solve one problem. Find the water equivalent. Find the water equivalent of copper block water equivalent of copper block of mass 200 gram of mass 200 gram. The specific heat of copper is, okay, you can write here given specific heat of copper, that is S of Cu, is equal to 0.09 calorie per gram degree Celsius. Calorie per gram degree Celsius is in the bracket. Now see how much easy problem they are asking, right? Yes or not? So let's start solving this. It is very, very easy. Can you do yourself? Yes, can you do? Okay, so let's see. So what is given here? Given, you see, given mass M is equal to how much? 200 gram. Next, specific heat of copper. How much it is? 0.09 calorie per gram degree Celsius. So both are in CGS units, so no need to convert anything. So what is W then? W is equal to MS formula we are having. So therefore W is equal to, this is for copper only, so I am not writing copper again here. So this is 200 into 0.09. Yes, how much you are getting? W is equal to 18 gram. That's it. Chinnam pillal vastu. Very, very easy problem, isn't it? Right? So note down this and try to do yourself. G is gram, not acceleration due to gravity. Otherwise, you will keep again 9.8. Babu, G is gram, okay, not 9.8. Otherwise, sir, W is equal to 18 into 9.8 means I penny. Okay, so that is gram. Okay, because that side straight line is going on. G means 9.8. Everywhere G consists 9.8. Yes or not? Here it is gram. Keep it in mind. Okay, so let's move ahead. Next problem. So next problem. A lead piece of mass 25 gram. A lead piece of mass 25 gram gives out 1200 calories. Gives out 1200 calories. Gives out 1200 calories. gives out 1200 calories of heat. When it is cooled from when it is cooled from 90 degrees Celsius to 10 degrees Celsius. What is its number one specific heat, number two thermal capacity, and number three water equivalent. Water equivalent. Water equivalent. Right? So let's solve it. So first you see what is given things here. M is given. How much is M? 25 gram. 25 gram. Okay. Next, delta Q is also there, right? Delta Q is given. How much it is? 1200 calories. Next, delta theta is also given. Delta theta is equal to 90 minus 10. How much? 80 degree Celsius. How much it is? 80 degree Celsius. Now number one, can you do yourself? You know delta Q is equal to what? M S delta theta. Therefore, S is equal to what, Babu? Delta Q by M into delta theta. Do it yourself. Second one, what he is asking? Thermal capacity, that is heat capacity. H is equal to what you are getting? M into S. Whatever M you are having in gram, specific heat in calorie per gram degree Celsius. You are getting this. You can do it. And third one, water equivalent W is equal to again M into S, that is in grams. Understand? Can you do yourself? It is very, very easy. Yes, it is very, very easy. Right? So do it yourself. Right? I hope you can do it now. Do it yourself. Okay. So let's stop here. Enjoy the day.